Even if you find a solution to the first problem, even if you have made sure that all programs that are used in your enterprise are updated, this does not automatically mean that you're secure. As you've seen in one of the earlier modules, even if a program itself is trustworthy, you can't know for sure whether at some point a malicious code was inserted to it or not, either prior to or at download. This strongly suggests that you shouldn't allow users to run any programs they want. We can now observe a slow departure from a model of universally used computers, this applies also to business machines, that are expected to run anything, in favor of a shift towards thinking of computers as a tool to perform specified tasks and functions only. How can you ensure this? You should make it impossible for users to run programs that you know to be harmful. But since no one knows of all dangerous programs, this has to be done in a different way. How? Users should not be able to run any programs. This would make a computer relatively secure. But if it's also to be functional as well, you'll need to create an exception list, a whitelist. Programs that are listed on the whitelist can be assumed to be secure. You install them yourself on client computers. They should be able to run on them. Let's now think of how this can be achieved. If you're using earlier editions of Windows, Windows XP and Vista or equivalent, software restrictions policies might be a useful technology. If you're using newer editions of Windows, software restriction policies have evolved to a newer version called Application Control Policies. Software restriction policies were problematic in use. Setting them up was relatively hard. It wasn't a hugely difficult task to understand them, but creating an exception list would take a lot of time. Generalizing some rules was not possible. Programs were identified based on their certificates, their file hash functions, paths, or internet zones. The last dubious idea was that if Internet Explorer was used to download a program, information about the source zone of the file, local intranet, internet, trusted sites, would be written to the program file. You could make decisions and identify a given code based on this. The policies don't have a rule that would, for example, allow running the Office suite both in its 2007 and 2010 version. We'd like to be able to create several rules or create path rules using wildcards. This type of rule specifies that you can run anything that is inside a folder or anything that is held in a given registry key. They're relatively dangerous. To allow a program to be run, you would only need to place it in an appropriate site. We, however, want these software restriction policies to work in addition to control and authorization mechanisms that were discussed earlier. They can't be based on this mechanism. There's no point in trying to create a list of native exceptions, or in other words, specifying programs that shouldn't be run. This wouldn't do much to secure your systems. You have to change fixed thought patterns and determine that nothing is allowed except the code and programs that are sure to be secure. Let's now examine mechanisms used to implement this. The first thing that is implemented in a real system that you will see there is a default security level. This is your starting point. If you don't change any settings, a default rule is that anything is allowed to be run. You can run anything you want on each of your computers. Then, as we mentioned, you have rules that identify software. You can then explicitly determine the identity of a program. If a program is signed digitally, it can be a certificate, a file hash rule, a hash function or hashing result, an internet zone, or a path. There are also extra settings that enable you to specify if this entire mechanism will also be applied to dynamic link libraries or to executable files only, or if it should be applied to administrators or exempt them. There's little point in exempting administrators. When you'll be configuring and enabling this, I have one valuable piece of advice. If something goes wrong and you block the ability to launch important operating system elements, you'll have problems, for example, logging onto the computer after restart. The safe mode is really useful in that case. The mechanisms don't work in safe mode. They're not run. You can then log on, reconfigure your settings, and see if they work. The order in which the rules are applied is known and well documented. They start with the most detailed and end with the most general one. This allows you to create exceptions. You can, for example, allow running programs that are contained in a given folder, except a file of a specified signature. At the end, a default security level rule is checked. Let's now say a few words about internal operating mechanisms. After enabling software restriction policies, the following startup methods for an application are controlled. This protection applies to a Windows API function known as createProcess. This mechanism is used to run new programs. Software restriction policies are usually applied to this function. Other elements that are controlled include NTDLL libraries, the kernel loader. In this case, there's a possibility to block the running of a part of an operating system. This could produce adverse byproducts that we mentioned before. A command line interface environment is also controlled. This is the CMD program. Control is also applied to all scripts, or to shell scripts and PowerShell scripts. An operating system will check the data contained in a registry key you can see. It contains information on policies set on a given computer. Before a code is run, it's checked if one of the rules applies to the program. If there's a match, an action for a given rule will be used. If there's no match, a default action for all rules will be used.